guys remember and you forgot everything else. That was really the whole reason I left. It had nothing to do with my wife's surgery. It was just I wanted to leave long enough so that, when someone goes away, you tend to only remember the good things about them. So I was hoping that you guys, that 2 weeks was enough for you to forget all the times where I didn't post stuff or I had errors in my slides or I told you I didn't have time for EI. Did it work? Do you guys remember me as a perfect person yet, or do I need to go away longer?
So I think it worked.
Excellent, outstanding. Yeah, I asked. Excellent, excellent. I asked Captain Forbes to really lower the bar while I was gone, so I'm really hoping. Well, I mean, that's assuming he taught. He told me he was going to teach, but I never actually checked Teams to see if he was holding class. Did you guys have class for the last 2 weeks?
No. I'm
okay.
kidding.
Well,
yeah, we did.
That's fine. That's fine. I'll tell you, most of this stuff is made up anyway. We just come up with it on the fly. And the real important thing, though, is I don't care about what he taught or how he taught it or if it was better or if you liked him better. All I really care about was what was his math, cartoon comic game like? Was it better than mine? Was it worse? Because that's where I put 95% of my lesson prep into, is picking the comic for the day. Yeah, what do you got? What do you got, Ryan?
There weren't any comics at all.
Oh, see, I can't. Then I can't ever leave. I'll let my wife know that that this is the last surgery she's allowed to have, and she'll understand. She understands that how important of a person I am, and that you guys come first. It was, even though I didn't know I was going to teach at the academy, I wrapped it into my wedding vows. It was, promise to love, honor, and obey unless Math 356 third period needs me. And she said, oh no, that's legit. I understand that. Which I will tell you guys, because several of you guys did ask, because you're all great people. My wife is doing surprisingly well. I feel weird saying when people ask how she's doing and saying she's doing great. She is doing great, but she's doing great. It's like conditional probability, right? She's doing great for a person who has had a hole cut in her stomach, all of her internal organs moved out of the way, part of her spine torn out and replaced, and then everything put back in, and then sent home with a bottle full of pills, a walker, and some granny socks to keep her from having an embolism. So based on those conditions, she's doing great. As far as a normal person, she's probably not going to beat any of you guys in the quarter mile. But she actually walked half a mile on her own on the treadmill at the lowest speed with a back brace on, but no walker. So that is good, because since we are such loving children and husband, we have been spending the last week and a half making fun of her for her, as we call it, her drug addiction, her walker, and the granny socks that she wears, and the sounds she makes every time she gets in and out of a chair. And we do it out of love, because this is how we can tell when she's better, because when she can start making, witty comebacks and burns to us, then we know she's doing well. So it's all out of love, and it's a complex process that we put together. It is not just because we're mean, petty people. I think is how I'm going to explain myself during the court martial. Anyway, the point is, don't get part of your spine replaced if you don't have to. It doesn't look fun. All right, we should talk about math. So I figured today what might be handy is to do a bit of a review. Part for you guys, but part for me, so I can kind of figure out where you guys are at. I'm sure that Captain Forbes did a fine job. He course directed this class before I did, so most of what I'm doing is based off things he invented anyway. So, but I know sometimes he uses different terms and different examples, so I just kind of want to see where you guys are at so that I can move forward on that. So let's do that. And then please interrupt me if you're like, that's not how we do it, sir, or I don't understand that, or something, because I want to figure out where we're all at. So we're in this block on linear regression. I mean, hopefully, if Captain Forbes just taught probability then I'll have a conversation with him. But we're in this regression block, right? Which is the idea of, we want to look at the relationship between variables. And this is the real equation, right? This is the one we wish we knew, but we will never know. It's theoretical, it's mythical, it's whatever you want to call it, right? Where y is the actual response variable, and beta naught and beta 1 are the actual parameters that if we had all the infinite data in the world, it would represent, that middle part there would represent the average of all possible values. But even if we knew that, we still wouldn't be able to predict the future exactly, because there's this error term, this epsilon, right? That even if we knew the exact average, actual values are distributed above and below that average line according to this normally distributed error, right? And so this top part here, this is reality, which uses parameters, beta naught and beta 1, that we will never know. And even if we did know them, it doesn't help us because we will never be able to predict this random variable epsilon, right? So this is the thing we want to know but don't. And so what we do instead is we try to predict it or estimate it using this least squares regression equation, where we put hats on everything to say our estimate of the response variable is equal to the estimate of our intercept plus the estimate of our slope times the actual predictor variable, because we're going to take an actual predictor variable and then we're going to try to estimate the response, right? This was the simple regression form. And then we saw that we could just keep on adding terms if we had more variables and say we have this multiple regression. But in either case, this is basically a linear estimate that uses the statistics beta naught hat and beta 1 hat, which we derive from some sample, and we ignore the error. At least we don't include it in our model. We're just trying to figure out this line that is our predictor with the understanding that it's an estimate and there's obviously going to be error. So before we go any further, do you guys have any questions or like things you want to check on as far as this concept between what reality is and how we are trying to estimate or predict reality with our regression equations? Yeah, what do you got, Ryan?
So on the lab, it asks like what all these are, whether they're like parameters or if they're independent variables or dependent variables. Can you kind of like go through that? Are you allowed to?
Sure. So in the top there, in the real equation, right, y is a response variable and x is a predictor variable. Beta naught and beta 1 are the parameters because they are the real thing. If you go way back to the beginning of this block and we said, hey, what percentage of people you saw are male? The real percentage of people that are male is the parameter, right? Then when we tried to estimate it with p hat, that was our statistic, right? So the parameters are usually the real values, right? So beta naught and beta 1 without hats, those are my real parameters that describe the real relationship between the predictor variable x and the response variable y. Some people might call x the independent variable and y the dependent variable because y depends on x, right? And then epsilon is it's a random variable because it is the error. It's saying even in the real world, if I knew the real linear relationship between two variables, even if it's really good, it's going to be the variables are going to be above and below that line, right? If I wanted to predict someone's height or someone's weight based on their height, even if I took everyone's value and was able to make a line, that line would only represent the exact average height of everyone. The real heights would be distributed above and below that according to this random variable of error, because if you're 72 inches, some people might be heavier, some people might be lighter than what the average of all 72-inch people are. So even when I knew all the data and the real parameters, I still have that random variable to show how the data is distributed in real life above and below that average. When we go to the bottom, x is still the same x, so that's still my independent predictor variable, but beta naught hat and beta 1 hat are both my statistics that I calculated that are estimates of the parameters beta naught and beta 1. And y hat, that is my predicted response variable. So it is my prediction of the response variable. It is still a dependent predicted response variable, but it is that hat that makes it the predicted response rather than the actual response variable. Does that answer what you're going at, or were you looking for something completely different and just didn't want to interrupt me?
I think that answers it perfectly. Thank you, sir.
Excellent. All right. So then from this, we kind of, like we did so many things in this course, we went from like the simple version and then we just kept adding on things, because this is one of the things I always think is great about math is when I talk to my kids, and I've talked at some of their schools sometimes, sometimes people, or when I used to teach high school, people will ask like, oh man, what's the hardest, math you've ever done? And I always tell them, and you guys are been far enough along that you know this is true, that math doesn't necessarily get harder, it just gets more specific, right? Like when you first say, how do you calculate velocity? Early on, you just go, oh, well, you figure out how far you went and divide it by how much time you took, and that's how fast you went. And then you get a little farther in physics, and they go, well, actually, we have to consider that you might have had a started velocity, and so add that on. And then you get into an aero class and they go, oh, well, there's actually wind resistance, so we should add that on. And then if you're trying to design satellites, you go, oh, well, actually, they're moving close enough as a fraction of a speed of light that we have to add these terms to account for special relativity and general relativity. And so it's still the same equation. It's just earlier on, you didn't care about the other part. And as you get more and more further, you go, oh, we could do better. We could do better. We could do better. And that's what we've been doing with regression, right? Because we started with this simple regression equation, which is wrong. I forgot to put a hat on y. And so the idea of this is saying, what if I have one response variable and one predictor variable, right? So let's say y is my salary, and let's say x is the number of years I spend at a company, which would be a numeric variable, right? I could get this regression equation where beta naught hat and beta 1 hat, those are my y-intercept and my slope, but they have meaning too, right? In this scenario, because beta naught hat is my estimate of the y-intercept, it is what I'm estimating your starting salary will be, right? Because in this case, this y-intercept means that x1 is 0, which means I've spent 0 years at the company. So that means beta naught hat is what is my salary for 0 years at the company, or my estimate of what your starting salary will be. Same thing with beta 1 hat. It's my slope, but it's my slope with respect to x1, which is the number of years at the company. So really what it is this is how much additional salary I am estimating you will get for every additional year you spend at the company, right? That's what these things mean. I always harp on that because as we get further on, it's not as easy to just explain things in terms of the slope. And so I think it's more important that we understand what they actually mean in a scenario, especially since this is 356. We're supposed to be applying it. You guys need to be able to explain what things mean, right? So then we added to multiple regression, which was the same idea, but we said, hey, maybe there are other predictor variables that I could that could account for it. For example, what about the number of overtime hours I spend? That's another numeric variable. But yes, my salary is going to go up for every additional hour of overtime I work. And so I can just add on another term, and I can now say, hey, now beta hat 2, that is my my estimate of how much additional salary you will get for every hour of overtime you worked, right? So, and this should have a hat too. And now this beta naught hat has a little bit of a different meaning, because now that is my starting salary, assuming I don't work any overtime, right? It is my intercept of everything being 0. And this is where I stop using the term slope as much, because slope doesn't have as much meaning here, right? Beta 1 hat is the slope for x1, and beta hat 2 is the slope for x2. But overall, this is no longer the equation for a line, right? This one here, I could visualize as a line with a intercept of beta naught hat and a slope of beta 1 hat. But that second one is not really the same anymore. Some of you guys have probably taken some higher math. Anyone have any guess at what that second, if I tried to graph that second equation, what it would actually look like?
A curve.
Yeah, not just a curve, it would be a plane. It would be a three-dimensional, because it's hard to, a lot of times you don't see it because when you think about 3D graphs, you think Z, X, and Y. But here my Y hat is like my Z, and my X1 and my X2 are like X and Y. And so this would be the equation for a flat plane in 3 space, right? Because I have 2 variables, X and Y, that are both deciding what my Z or my salary is. And so it gets real complicated to graph real fast as we add different variables. So that's why we start to not try to visualize it as much as we add more and more variables. It gets complicated real fast, but it is less complicated to understand what those coefficients mean. We can still talk about them in these terms. Okay, and then we said, well, what if I wanted to add a variable into multiple regression, but it wasn't numerical, right? It was categorical. So before we said, up until this point, we said, I'm going to use years at the company and the number of overtime hours I spend as my predictor variables. But what if I wanted to add the predictor variable of what's your highest education level? And to make things simple, let's say your highest education level is either high school, college, or grad school, right? That is a variable. It definitely has an impact, most likely, on how much money you make, but it's not a number that I can just do with the slope, right? And so for categorical variables, what we saw was that we had to add these, account for them with these dummy variables, or what I believe the book calls indicator variables. And so in this case, because I have one categorical variable, what's your school level, it has 3 possible values: high school, college, and grad school. And because it has 3 possible values, I have to add 2 indicator variables, right? Because with 2 indicator variables, I can say, hey, if X3 is 1, then everything else is 0 and you went to college. If X4 is 1 and everything else is 0, then that means you went to grad school. If both of them are 0, then that means you went to high school. This is why I only need 2 variables to explain 3 levels, because I basically say, hey, X3 is 1 if you went to college, X4 is 1 if you went to grad school. And so if neither of them are 1, then you didn't go to college and you didn't go to grad school. The only option left is high school. And so I know you went to high school. And so I add these, by adding these indicator variables for the categoricals, I can now do this multiple regression with categorical variables, right? So at the end here, if I went to college, then X3 is 1, and that term, and then it also means that X4 has to be 0. So if I went to college, X3 is 1, X4 is 0, which means this term turns off, it goes away, because X4 is 0, so it doesn't matter what B4 is, that's 0. This term turns on because X3 is 1, and that means I am now, whatever I had before, I am adding beta naught 3 to it. So when I have these indicator variables, this is basically giving me a way to adjust the y-intercept. Because if we think about this as a graph, if I have some graph and I say, hey, my simple regression is that y hat equals beta naught hat plus beta 1 hat x1, then I could draw that as this, where my slope, I don't know, that's how I'm going to draw the slope, is beta 1 hat, and my y-intercept is beta naught hat. That's the simple regression. But if I wanted to add a categorical variable, and let's make it easier and just say that it's my gender, right? Then I could say, okay, gender has 2 possible values, if we're not going to add any kind of cisgender terms. And so since it has 2 possible values, I have to add 1 indicator variable. So I'm going to add a new indicator variable, x2, and I'm going to say it's 1 if you are male, and which means that if it's not 1, then you are female. And I add this new term up here, beta 2 hat x2. And so if x2 is 0, that term goes away, and I get the equation, I get the regression line I already had, right? So the beta naught hat intercept, that is the intercept for being female. So that is the the base value for being female is wrapped into beta naught because that's our reference level, because that's when all the indicator variables are 0. If you are male, then this one turns on, and I am now adding beta 2 hat to the entire equation, which means I take my entire line and I add beta 2 hat to it, and now my intercept was beta naught hat plus beta 2 hat. That is my new intercept, and then everything else is the same, right? And so that's how we account for those categoricals. So if I think about, in this case, beta 2 hat, the meaning of it is the additional, whatever I'm measuring here, let's say it's salary, it's the additional salary I expect for a male to get over what a female gets. Any questions on any of what we had here or what we were talking about here, or anything you'd like to see?
Yes, sir. I got a quick question for you. So it makes sense as far as defining the variables, but how would you go about calculating what your what your B2 would be?
Sure. So that would just be in I would do that in R. I would have no desire to do that by hand. So if I in R said, hey, give me a linear model, in this case, let's say that this was that I was trying to do salary was my Y and X1 was my years, and X2 is my I don't even have to give, let's just say I'm trying to do gender, and I'm trying to predict salary based on years and gender. I would say LM sal based on years plus gender. And then it would create this table down here where it would say, hey, your intercept estimate is whatever. It would have a number there for beta naught, and then it would say years, and it would have another number. It would have another number here, and then it would have gender, and it would say male, and then it would have a number here, and that would be this number would be the estimate for the coefficient for when male is 1. And then if you wanted to know, hey, what's the y-intercept for male, it would be this intercept, which is the reference intercept, which is what it would be for female, plus what it would be for male. I've got some R code later in the lesson we can look at, because I realized that got a little messy and shoved into the corner there. Does that kind of generally get to where you're looking at, or are you looking for something more specific?
No, sir. I think that answers my question.
Okay, yeah, and just remember when we get to the code again, I will ask you to, when we look at the actual code, to see if that makes more sense. Avery, what do you got?
Sir, I'm still confused how it's plotted. So are you going to have as many lines as you have those indicator variables, or is it?
So this is where it gets a little complicated, because, and this is why I said it can help to visualize things, but the actual equation is going to look a little strange, because what's going to happen is I will have something like, let's say I have, let's make this really obvious and say I have data that looks like this, right? And so let's say this is the data for the what we were just talking about, and these are observations that are male, and these are observations that are female. So when I look at it just with my eyes, I go, hey, obviously they have the, and let's say this axis is years at the company, and this axis is salary, right? And so if they were all in one, if I just did a simple linear regression, it would probably make a line that looked like this, because it would try to do a linear regression between them, and it would just split the difference and go straight down there. And that would be my simple regression equation, which would be something like y hat equals beta naught plus beta 1 x1, right? Where x1 is years. And so that would be the simple analysis. If I wanted to say, hey, there's something else going on there, and it's whether or not they're male or female, I would make this new equation, y hat equals beta naught hat plus beta 1 hat x1 plus beta 2 hat x2, where x2, like we said, is 1 for male and 0 for female. And so when I look at that, I can visualize it as saying what's kind of going on here is that when x2 is on, then I am considering this line up here, and when x2 is off, I am considering this line here. But it is a single equation. Really, if I really wanted to plot this, it should be a three-dimensional graph, and it gets harder to figure out what's going on, because what's really happening is that those two sets of data are on a plane, and I could try to draw it, but it's going to look really bad real fast. But what's really happening is I have salary going up, and then on the floor I have over here is years, and over here is your gender of either 0 or 1, and I have this like plane up here where the two lines are sitting on that plane depending on if it's male or female. I'm just visualizing and saying you can think of it as two separate equations. You can think of it as an adjustment to one, but that's really not what's happening when I draw it. Does that kind of help, or does that complicate it more?
That was helpful, sir. Thank you.
Okay. Yeah, like I said, so much of what I do is like, that's why I really like George Box's quote, all models are wrong, some are useful, right? It's kind of like the same thing can be applied to my lessons. All descriptions are wrong, some are useful, right? Trying to describe what's going on is an adjustment to the y-intercept is helpful if you visualize that, it helps. But if not, and you're a pure math person who's like, no, that's not what the equation is. The equation is a 3D plane, then it doesn't help. So always feel free to ask me questions on that, because I'm trying to explain what I think is useful, but you could find some level on which that I'm mathematically wrong, and I can describe it another way. So please always interrupt me. Don't just go, well, I guess I thought I understood math, but I guess that's one more thing I can add to the list of things that doesn't make sense in the world, because you're probably right. All right. Any questions before we get on to what we were talking about today? Awesome sauce. Okay, so here is a set of data. So good data, if it's labeled well and it makes sense, should kind of stand on its own. So before I even explain anything, let me ask Michaela, if you were just given this, like let's say you're a second lieutenant and I am a horrible boss, and so I just gave you this sheet of paper and said, hey, this is going to be on a slide. I got to bounce. Can you explain this to the people in the conference room? I'll talk to you later. Good luck. What would your explanation of this slide be?
Just like what I'm seeing.
Yeah.
So it's showing the relationship between hours studied and the grade received on the final score. And it looks like there's 3 different trends. So I'm assuming maybe it's like 3 different instructors or something like that.
And is there any relationship?
Yes, there's a pretty strong linear relationship. But I mean,
okay, so
for separately, but for all 3 of them.
I see, and so you see, you're getting some real good subtle information there. You're saying, hey, you already recognize that this is looking at a relationship between Calc 3 final score and hours studied, but then you also, without being told, were able to acknowledge there seems to be some, it's a bunch of data, but it seems like there might be some subsets, and it looks like there is a relationship, but it looks like maybe it's different for different things. And so this is why humans are still in the loop when it comes to statistics, because you were able to figure out all of that on your own. If I just showed this picture to R, it'd be like, what do you want me to do with this? Do you want me to do regression? I don't understand what we're talking about. It's dots. You gotta give me more information. So let's give that a little more information. Say, so definitely our response variable is the score on the Calc 3 final. And our numeric variable is the number of hours that you studied, right? But we also have, it's not as obvious here, but Michaela was starting to pick up on it. There is some additional information that you can't immediately see on here that I know is a categorical variable, which is what is the highest math class you took. And it could be either Calc 1, Calc 2, or Calc 3, right? So I have 4 different variables here, a response variable, a predictor variable, and then I have a categorical variable that I am representing with 2 indicator variables because it has 3 possible values. So I'm going to represent it by 2 indicator variables. So let me ask, John, you online?
Yes, sir, I'm here.
All right, so do you think a linear regression would be appropriate here?
I think if you could do it like on the individual sections, then yeah.
So wait a second. So you're telling me if I just do a linear regression and all the data like that, and that's what R gave me, you're telling me that that simple regression is not good enough? You would not be comfortable turning that in?
No, sir.
Okay, so you want to do, instead of simple regression, what kind of regression would you like to do?
I'm not sure what the word for it would be, sir.
All right, here's all your terms. Which one do you want to do?
I think multiple regression.
Okay, so let's do multiple regression. So there's simple regression, which apparently is not good enough for John because he's got high standards. So let's do multiple regression. There's multiple regression. Better or worse? What do you think?
It's definitely better, but didn't quite get the first 2. So maybe
Okay, so
categories.
when you say it didn't get the first 2, what is your problem with the green and blue lines? It goes through the clouded data. How picky are you going to be?
It just doesn't match it well.
What aspect of it do you think the intercept is off? What needs to be, because we accounted in this multiple regression, we said, hey, I'm going to add the categorical variables on the to the mix, right? I've got X2 and X3 in there. And so those last 2 terms, these right here, are allowing me to have a different slope for Calc 1, Calc 2, and Calc 3. So what is going on? What would you, even if you don't explain it mathematically, what would you like to do with that green and blue line that you would think would make it better?
I think they just need higher slopes so they actually like the data better.
So, okay, so he's saying slopes, right? Which is exactly what we were talking about. So can I assume that looks more like what you want?
Yes, sir.
So what he wanted, even though he could not articulate it, is he wanted multiple regression with categorical variables and with interactions. Because what he is saying is when we just did the multiple regression, that was saying, hey, I think that I think the value of this categorical variable has an impact, right? And so we added these indicator variables, which basically say, hey, when X2 is on, then add in an additional, make a modification to the y-intercept. If X3 is on, make a modification to the y-intercept. But what John is saying is, that's a good start, but it's not just that the intercept has changed based on what your highest math class is. The slope is changing as well, meaning there is an interaction, meaning before I had just X1 by itself, but now I have these interaction terms where I have 2 variables in the term because the number of hours you study has an interaction with what calc class you are. How much of an impact hours studied has depends on or interacts with the highest level of your of math that you've taken. And so in the same way that originally the indicator variables allowed us to make adjustments to the intercept, the interaction terms allow us to make an adjustment to the slope. Because if I'm in Calc 2, right, then that means that X2 equals 1, right? And X3 equals 0. So X3 equals 0, that term goes away. But X2 equals 1, which means that term that I just circled turns on, right? So that term becomes B4 hat times X1. well, I still have this original term with x1, and since those both have x1 in them, I could add them together and they would turn into b hat 1 plus b hat 4 times x1. And so what that term is it's adjusting the slope of x1. It's saying what the slope of how much I get out of studying increases if I'm in Calc 2. And then if I was in Calc 3, then x3 would be 1 and x2 would be 0. So this would go away and this would turn on. And now if I'm in Calc 3, the slope becomes b1 hat plus b5 hat times x1. And that is now the slope that I have here. So going back to what Avery said, we are basically, like what she said, we're basically cheating, right? Because what we are doing is we are making 3 different equations, but we are hiding them all in one big equation where we're just turning off and on parts based on the value of those indicator variables to make it work. You might say, well, then why are we doing it all in one equation? Couldn't we just divide the data up and subset it into a set of Calc 1 data, a set of Calc 2 data, and a set of Calc 3 data, and do a regression on each one? You totally could. But the problem is, as the number of categorical variables gets higher, you get more and more and more lines, and it gets really complicated. I know you guys are tired of hearing me talk about my dissertation, but it's just my best frame of reference. I had a regression equation in there that had over 10,000 variables. And a good number of them, at least half or more, were these categorical variables. And so I could have done it as 6,000 separate sets and separate equations. But that would have got real messy real fast. It is much easier to do things as a big linear regression where we're basically cheating and saying, how longer can we pretend we're dealing with a linear equation? I don't know if you guys have ever had the enjoyment of having Dr. Hertzinger as a teacher, but one of my favorite explanations, he reduced all of calculus into one sentence, and his summary of calculus is: curvy things are difficult, straight things are easier. Let's pretend the curvy things are straight, right? That is basically all of calculus, saying, hey, what's the slope of this line? Oh, I can do it real easy. What's the slope of this curved line? I don't know. Well, if I look at it really close, it looks like it's straight. Let's pretend it's straight. That's what the derivative is, right? Looking at little differentials, right? Same thing here. Doing a bunch of, doing linear regression, simple regression is easier. And so I could do a bunch of more models, but then we keep going, oh, could we pretend that it was one model? And that's what these indicator variables and the interactions allow us to do, is to just keep doing it. Because yes, there are nonlinear regression and things we can do, and we'll get a little taste of that like in our last lesson, but it's not fun. And so we fight and do everything we can to just keep shoving everything in and pretending that it is one single linear equation. All right, I got a lot of stuff drawn on my screen. Let me get rid of it. Questions about the concept and idea of what's going on here before we look at the code of how to actually calculate it and create it? One thing I want to make sure I foot stomp on here, because it's where a lot of people get confused, is that I have my categorical variable is what is my math class, right? So that's one variable. It has 3 possible values. And because it has 3 possible values, I had to add 2 indicator variables. I added 1 less than the number of values, right? And so because I added 1 less, x2 is 1 if I'm in Calc 2. If I'm in Calc 3, then instead x3 is 1. If I'm not in Calc 2 and I'm not in Calc 3, then that's 0 and that's 0. And then I don't need another variable to tell me that I'm in Calc 1, because I'm not in Calc 2 and I'm not in Calc 3. So that means I'm in Calc 1. But more importantly, what that means is this is the intercept for Calc 1, because there's no term for Calc 1. So that is the reference variable. What you would get for Calc 1 without studying is beta naught hat. Similarly, the basic slope here is the slope for my reference level for Calc 1. That's why actually when we went back here, the Calc 1 looked great because it was the reference level. It was the one that everything was based off of. And then these just look bad because we didn't have the interaction terms and we couldn't change the slope. So the everything is in comparison to the reference level. So let's look at the code and see if we can get a little better understanding. So hopefully a lot of this looks similar to what you have seen up to this point. So up at the top there, we're going to build a linear model. And I probably could have chosen better variable names, but I used calc as my variable name for what is your score on the Calc 3 final. And then study is the number of hours you spent studying. And then level is what is the highest level of calculus that you have taken. The new part that we haven't seen before is this right here. If I say, now add in study colon level, that is going to say, I also want you to consider the interaction between studying and level. Basically, how does the number of hours you study, the importance of that change based on your level of calculus that you've taken. And then we get the same type of output that we've got before, just more terms, right? So I have this intercept right here, and that is my estimate for beta naught. This is my beta naught hat. So let me ask who's online? Nestor, you online?
Yes, sir.
So give me your best shot at explaining in your own words, what do you think 40.72946 means for us in this scenario as it's listed there?
So basically 40.72 means that if you haven't studied at all and if you haven't taken Calc 2 or Calc 3, that is what you can expect to get. That's basically
exactly. And the second part that he said is in my opinion, is the more important part and the part that people struggle with. Mathematically, it's the intercept. But more importantly, what that means is that is the score I expect you to get if you haven't studied at all and you are in Calc 1, or as he put it, you're not in Calc 2 and Calc 3, right? So that is the score for a Calc 1 student who hasn't studied at all. So by that same definition, let me ask Luke, are you online?
Yes, sir.
On that same token, help me out with this right here, 0.95710. Give me your best shot on explaining what that means for us in this scenario.
So that would be how much your score would increase per hour of studying if you were in Calc 1.
Exactly. That is the perfect answer. Oh, I feel like just turning it off right now and walking away. This is the third class I've taught, and this is the first person who you've described it succinctly and in a very nice, easy to order and hit all the points. It is how much your score would change for every additional hour you would study, given you were in Calc 1. Perfect. All right, excellent. All right, so now let's make it a little harder. Let's go for Trevor. You online? I know no one ever wants to answer me when I say, let's make it harder, and then I say your name. I should probably say, who wants candy? Trevor.
Yes, sir.
Okay, sorry, no candy. But let's look at this one. So this is the coefficient for level 2, which is an indicator variable that can be 1 or 0. What does 19.25838 mean in this scenario? Best shot.
I think you've already covered the intercept, so geez.
So I'll give you some help here. So if we go back to this equation, the coefficient that we are talking, so we talked about this right here. That was the intercept. That was the score you got if you didn't study and you were in Calc 1. Then we looked at this right here, and that was the slope, basically saying that's how much additional points you get for every hour you study, assuming you were in Calc 1. Now we are looking at this coefficient. This is the coefficient we're looking at now, which is the coefficient for x2, which x2 is 1, when you are in Calc 2. So what does that coefficient being about 19 mean in our scenario?
So it looks like to me then it's a similar one to the last one, like in terms of for every incremental hour that you study, provided you're a Calc 2, student.
Now I will
how
say,
much your score will increase.
I will say, what is the variable for how many hours you study?
X1.
Right. So there's no X1 in this term. So beta hat 2 is not dependent on X1. It's dependent on X2, which only has to do with what?
Whether or not you have completed Calc 2.
So if you completed Calc 2, then what does beta hat 2 X2 become?
That entire term is just beta hat 2, the value of beta
Right,
hat
which
2.
which in our case is, which we showed on the next slide, is 19.25. So if you're in Calc 2, what does that term add to the equation?
It adds. It almost looks like it shows how much more proficiency you'd have just from having completed Calc 2.
Yeah. So and we're beating around the bush. We're getting to the point where I'm trying to get you to guess exactly what I'm thinking in my brain. But you basically said it, right? This does not depend. This term does not depend on the number of hours you studied. It's just how much. It's an adjustment to the y-intercept. It's basically saying this is the amount more you would get on the exam if you didn't study at all, if you were a Calc 2 student over a Calc 1 student, right? This is the y, if we look over here, this is 0 hours study, right? So this was the y-intercept for if you were in Calc 1, whereas if you were in Calc 2, it is right here, right? So that is the intercept for that one. So going back to here, 19.25, what that is saying is that is how many additional points you would get on the test without studying at all if you were a Calc 2 student instead of a Calc 1 student. Does that make sense, or did I confuse it?
No, I get you now.
Okay, so then if you got that, then let me give you a follow-up question and say, let me ask it a different way. So let's say that you are in Calc 3, but somehow you're still a slacker and you didn't study at all. What is your expected grade on the final if you were a Calc 3 student and you didn't study at all?
Basically the sum of the intercept level 2 and level 3.
Very close, but off by just a little bit. So it is the sum of this and this, but not that, because the level 2 and the level 3 are the individual adjustments for Calc 2 and Calc 3. So when I look at that 30.09262, that is not how much better you'll do in Calc 3 in compared to Calc 2. It's how much better you would do in Calc 3 compared to Calc 1. Everything is compared to the reference level. It's not a incremental, we keep going, which kind of, I see how that makes sense, but it is all compared to the reference level. And so you would get about a 71, right? Because you would do 30.09 better than the 40.72. Does that track?
Yeah, that makes sense too.
Yep, excellent. No, and I'll be honest, I purposely put you in there hoping you were going to give me the wrong answer. I may have even asked it in a way that pushed you towards that because I wanted to make that point. So I apologize, but I appreciate you being my guinea pig so I could make the point.
No problem.
Okay.
I think I got it now.
You're like, you know what? I've been at USAFA long enough. I'm used to being a guinea pig, sir. I'm pretty sure that I don't know what kind of drugs they're putting in Mitch's. I'm sure I'm on several other test regimes that I don't even know about. At least you're honest about me being a guinea pig. Okay, so last part is the last two, which I'm just going to hit because we're running out of time. But so what this is right here, this is the interaction between study and level. So this gets to what we were kind of talking about earlier, but we're a little off on. That is, how much do I need to adjust the slope of study if I am in Calc 2? So this is saying that 2.06718 is saying if I am in Calc 2, then I will get an additional 2.06 points for every hour I study more than if I was in Calc 1, which means since I get in Calc 1 0.95, that means that in general, if I'm in Calc 2, I get approximately 3 points more for every hour I study, because this is the adjustment to the slope of study over the reference level, which is here. If I look down here at Calc 3, it's 4.75, which adding that, that's about 5.7. So a Calc 3 person gets about 4.7 hours more, or 4.75 points more out of every hour they study than a Calc 1 person does, which means in total, they get about 5.7 more points for every hour they study. All right. I know that's a little bit of an abrupt end, but you guys asked some really good questions. So we went down a couple of paths that I hope were helpful. If not, we will hit a little more review tomorrow. I am catching up, but I am back. So you guys can feel free to shoot me any messages, schedule any EI. Be aware that I've still got some doctor's appointments I got to do with my wife and drive her around. So my EI time might be a little bit more limited, but I will make it work. I've also fell behind on your Lab 8, but I'm going to get those graded, even if it means I got to not do the comments. Just get you guys scores so you know where you stand. Otherwise, I'm glad to be back. I know it sounds weird, but I missed you guys, and I'm glad to be here. I will see you on Wednesday, if not before then. And if it is still possible, try to have a great Monday.